Hello everyone, welcome to week 4 of our computer graphics videos. This week we are going to discuss about clipping. Here I am discussing about Cohen-Sutherland line clipping. So what exactly this clipping algorithm is about is being explained through this image. As you can see here, we have a window. The window is depicted by this blue color, and we have three lines. One line lines partially inside and partially outside, so one of the endpoints is partially outside the window and partially inside the window. Another line has is completely inside the window, so both the endpoints are inside the window, the blue region, and third line is completely outside our blue region, the window. So the way we tackle this issue, the way we clip these lines, uh, by that I mean, for this line which is partially inside and partially outside, we need to clip it at the point of intersection of the line and the window, so that only the part which is inside the window is seen. The line which is completely inside the window stays as it is, and the line which is completely outside the window gets removed completely. So we assign region codes, binary codes, 4-bit, to all the regions. As you can see, we have 8 exterior regions and 1 interior regions to the window. The region inside the window has a binary value of 0000. The region to the left of xmin, so xmin is depicted by this line here. The leftmost part of the window is depicted by a 1 in its first bit, and as you can see, the top left is depicted by 1001 because it is a mixture of region to the left and region to the top. And as you can clearly see, region to the top has its last bit equal to 1. So that is how this region, the top left region, has a binary bit value of 1001, and similarly we assign region codes to all the other regions here. Then the next step that is involved in this is that we look at the endpoints of the line. So here, as you can see, this endpoint of this line lies in the region 1001 and 0000. So what we essentially do is we perform an AND operation to AND operation of the binary values. So AND of 1001 and 0000, it is definitely not equal to 0000 because we have two ones there, and in that situation we conclude that the line is partially inside and partially outside. So if we perform an AND and we find that all the bits are zeros, then we know that the line is completely outside. And if we perform an OR of the two values and we see that all bits are zeros, then we conclude that the line is completely inside our window. So that is the Cohen-Sutherland algorithm, and it is depicted here in the form of code. So our code essentially converts that algorithm that we just talked about in Python, and demonstrates this phenomenon on a T-Intel low resolution graphics board. So as you can see here, we have variables that define where the endpoints lie. So for endpoints inside we have a value of 0, for left we have 1, for right we have 2 depicts the 0010 value, 4 depicts the 0100 value for bottom, and top is 8 1000. And then we go on to check which region our point belongs to first, and after we have done so, as you can see, we have used the compute code function to check which region our endpoints belong to. The code 1 belongs to endpoint 1 and code 2 belongs to endpoint 2, and depending upon the codes, first we AND both of the codes, then we check what's the value of ANDing the two codes and which region it essentially belongs to, using the conclusions that we just discussed. So the output of this code looks like that. So I have three lines actually. I have 3 lines. One line is completely outside, one line is partially inside and partially outside the window, and the third line is completely in. Okay, I have both of the lines partially inside and partially outside here. So as you can see, the gray part is a part of line that's outside the window, and the colored part, the blue and green part, is inside the window. And this is the black rectangle is basically our window. So this algorithm was designed in a way that it changes the line color for the part of the line that is inside the window. So that is how coincidental line algorithm works, and it is a little, um, I would say, it uses a lot more computations than other better algorithms that we have, like algorithms that use parametric equations to do all of this that we have done in just 2 steps. But this is the basic algorithm that was developed by Cohen and Sutherland to demonstrate how line clipping works.
So now we'll be looking at polygon clipping using the algorithm that was defined by Sutherland and Hodgman. And this is basically 2D polygon clipping. And the code that we've written actually does it lets you input both the polygon figure, and the clipping window can also be a polygon. So giving you a small demo of how that happens. Let me just start the program. So here the first thing that we do is we draw our polygon, and you can do that however you want. You can add a little few edges and make it as fun and fancy as you want. Once you're done with that, you right click to move into the window drawing mode, and you draw the little window. So I'm choosing these 4 points as my current window, and that's the window that we'll be using to clip. And then I press the middle mouse button to basically get the results. Now the results are saved in a folder called images, and I'll just go through each of the images to show you what exactly is happening. So as you know that our window has 4 edges, and the algorithm goes and basically clips everything according to those edges. So here you can see the initial image. This is being cropped according to the first edge, and then we move in a counterclockwise fashion. So after this edge, we have the next edge that's being clipped, followed by the other one, followed by the last edge, and that gives us the output image. Now, I'll just give you another demo, removing these files. I'll give you another demo with a window that has more than 4 vertices, and you'll get a better understanding of how exactly this works. So 1, 2, 3, 4, and 5. That's my second right click, the middle mouse button, and this is the output that I've got. So you start with this edge, and then you move in a counterclockwise fashion. So that gets clipped, that gets clipped, that gets clipped, and that end point, actually nothing there gets clipped, but yeah. And that's the output that you get for that image. So now how we do this, jumping into the code, we start with the drawer class, which basically makes that whole window that we saw. There are 3 basic um, button events. Mouse button 1 is your left mouse button, button 3 is your right mouse button, and button 2 is your middle mouse button. Button 1 basically tells you which points are being selected, and as you select points, it creates a polygon. So now this basically is used to create both the first as well as the second polygons that you saw, as in the figure as well as the clipping window that we want. Once we have those values, we have a function called getVals, which basically returns, which based on the parameter given, returns either the figures points or the windows points. Then we have our driver code. Now the driver code, what it does is it starts over here. So we're using the PIL, the pillow library, which actually draws the lines and the cropping thing that you guys saw. We create a canvas, and then we call the drawer class, and we draw both the polygon as well as the clipping window. We print out those values over here, and then what we do is we go through each of the vertices over there, and we tell the function to clip it. Once we clip it, we are also asked to draw a line, the blue color line that you basically saw, and save one version of the image so that we can view it later. How the clipping function works, it's very similar to the algorithm. So as you know, in the algorithm, depending on whether the line is moving from outside to inside or inside to outside, or if the line is fully inside or if the line is fully outside, we have four cases. So those four cases are taken care of over here. So if both the vertices are inside, then you append n, which is basically the whole line. If neither are inside, then you pass and you move on to the next case. If so, now you find if the line basically is moving from inside to outside or from outside to inside, you find the intersection point. Now, if it's moving from inside to outside, then we add only the intersection point to the final list. But if it's moving from outside to inside, then we add both the intersection point as well as the ending point, which is inside the polygon. So we do that over here. That's this function. And the intersection is found using the algorithm discussed before. It uses a parametric function and kind of figures out where exactly that intersection is happening. So yeah, that's about the Sutherland-Hodgman algorithm. Code will be freely available. Giving you one more demo just for fun. Let's see some different sort of polygon, something like that. And our window this time is going to be a triangle, because why not? And let's see our output. So it starts like this. That's the first edge getting clipped, second edge getting clipped, third edge getting clipped, and that's our final output. There you go. Thank you.